Okay, so I'm about to show you what I did for the Chapter 5 assignment. So everything is loaded up. I already ran 2 of the tests because I was trying to do a previous recording, and I stopped it, and it took off half of what I was doing. So this is a redo. This is technically a redo video, but nonetheless, I'm still running it. So I'll just take you back to what I did first. So, the first task that I tackled was the chick flick data set. So the first thing I was asked to do is to provide descriptive statistics for chick flick films specifically, well, for arousal films, all that stuff. So the first thing I did was use the by function, and I was given 2 sets of data splits. Yeah. So specifically, we're going to be looking at skewness and kurtosis. Skewness essentially refers to the pileup of data on a certain side. So if you have if you have a positive value for skewness, that means your data is more so going to be piling up on the left side, whereas negative values for skewness means that your data is going to more so pile up on the right side. Kurtosis essentially refers to the peakness or pointiness of a distribution. It also refers to the tail. So a positive value of kurtosis indicates that we're going to have a pointy distribution, and a heavy-tailed one at that. Negative value for kurtosis essentially refers to a flatter and lighter tail distribution. When I plot my histograms for Bridget Jones's Diary and Memento, I'll refer back to that. But nonetheless, so really quickly, looking at our skewness for Bridget Jones's Diary, we have a negative value. So this means that our data is going to be piling up more so on the right side. And also here, we have a negative value for kurtosis. So this means that our data distribution is going to be flatter and lighter tailed. Now looking at Memento, we have a positive skew, which is pretty good, but it's not close to, it's enough. So with this positive value, we know that we're going to have more so of our data piling up on the right side. On the left side of the distribution. And then for our kurtosis, we have a negative value. So this means that we're going to have a flatter and lighter tail distribution. So in order to test, I was also asked to test normality and homogeneity of variances. So the first test that I ran was the Shapiro-Wilks test. So this test essentially tests normality, and what this means is it looks to see if the distribution of data is significantly different from normal distribution. So I ran that, and here for Bridget Jones's Diary, we have a p-value of 0.7876. With p-values for Shapiro-Wilks test, if our p-value is greater than 0.05 or 0.005, if that's where you want to go, this means that our data, our distribution of data, is significantly different from the normal distribution. So there's no normality there. So here we have a p-value of 0.7876, like I said before, and it's greater than 0.05 and 0.005. So this means that our distribution of data is not significantly different. So that means we can assume normality for this case, for Bridget Jones's Diary. Now Memento is also not significant. So here, looking at our p-value of 0.5516, this indicates that our distribution of data is not significantly different from the normal distribution. So once again, we can assume normality. Yay. Now, testing homogeneity of variances, we're going to be using Levine's test. So essentially, Levine's test essentially tests homogeneity of variances. So what this means is that it tests to see if the variances of different groups are essentially equal. In this case, we don't want a significant result, well, p-value, what have you, because if we do get a significant value, this means that the variances are different from one another, and the assumption for homogeneity of variance is violated. So we're going to run it. Let's see what happens. Okay. So specifically, the value we're going to be looking at is PR, and well, just PR, this value right here. And we're given a value 0.1871. This is not bigger than 0.05, obviously. So this is good. What this means is that we can safely say that we can assume that there is homogeneity of variances. So our variances aren't essentially different from one another. So this is great. Yay. So now we're going to do the histograms. So I'm going to run this, run that too, run it, and all right. So essentially what pulls up is Bridget Jones's diary histogram. Now remember that Bridget Jones's values for skewness and kurtosis were negative. So what we see here is that our data is more so piling up towards the right side, and we also have a flatter distribution, and it's also lighter tailed. So essentially this we already knew this. Now running, well, not running, but we're just gonna do our histogram from Memento. I don't know why I say running, but okay, I'll run with it. So I'm gonna run this. This is the overall command that I ran. Okay. So now what we know about the value of skewness and kurtosis for Memento. I know it's not titled, but this is what it is. This is what we expected from Memento. It has a positive value for skewness. So more so the data is leaning, well, gathering up towards the left side. But we also have a negative kurtosis value, and this is why we get this flatter, not really peaky, pointy distribution. We also have a lighter distribution as well. So yeah, that's that. So now we're gonna move on to task 2, and that essentially refers to our exam. So I'm gonna run this in the library just to load up that data. I didn't load up this data, so you got me there. Attach. So essentially we're asked to run, we'll make up a histogram for numeracy. So we're going to do this. It was also asked if numeracy scores were positively or negatively skewed. As you can see from this histogram here, it is positively skewed. All the data is piling up towards the left side, And obviously it must have some kind of negative value because this, yeah, not a lot of stuff here. And also, it's extremely flat. So we're also asked to transform the data. So that's what we're going to do. But we can't just use any kind of transformation. We have to be logical about this. So when we're trying to correct positive skew, we can use, we can take the log, we can do a log transformation, which essentially takes a log of a set of numbers and it squashes the right tail of distribution. And we can also do a square root transformation, which takes the square root of each score and essentially moves it toward the center. So whenever I plot this, whenever I make this histogram, I'm gonna explain that again. So we're gonna do our exam, and essentially we're telling R to take the log of the numeracy scores. What I just ran was the square root transformation, and essentially this command tells R to take the square root of the numeracy scores, and we're going to see that it's pushing it to the right, but we haven't got there yet with the histogram. So now we're going to plot. Now we're going to make the histogram. Yep. Okay. So here, essentially we can see that our data has been changed. Just go back real quickly. So this is the before, and this is the after. So it looks like the data was pushed towards the center. It really wasn't. All it essentially did was once again take the log of the numeracy scores. Yeah, so it essentially reduced the positive skewness of it. So, yeah. So now we are going to plot the square root numeracy scores transformation data. Yeah. So ran that. Run. Okay. So what we see now is well, let's go back once again. Nope. Here you go. So this is the pre-transformed numeracy scores. Once again, that positive skew. Not you, but here. So what we notice here is that it essentially corrected that positive skew, and it pushed the data towards the center. Towards the center here. And what else was I supposed to say about this assignment? Oh yeah, if it became normal, why or not? So essentially, when we transform our data, we're not necessarily we're not essentially changing the norm. Well, kind of, sort of. Well, anyways, let me get back to the main point. So with the square root, with taking the square root of your data, you're essentially moving everything towards the center. So basically, it's taking the square root for your scores. It'll bring any of your bigger scores closer to the center. Essentially, we reduce that positive skew here. Did it become normal? It looks it. However, not really. So yeah, that's it. Bye.